Greetings and welcome back to the lab. Today I want to do a clock kit. Now I did one off camera, but it's far too complicated for right now. And actually, as it turns out, they sent me two of them by accident. So later on I can build that one, but that was one that had a lot of surface mount on it, and I think that's an advanced project. So I have this one, which is not surface mount. This one is made in China. Really just a bunch of numbers and a barcode. Oops, sorry, I'm out of frame there. And it just says made in China. Now, before I dive too deep into this, let's take a look at the listing that I bought this off of. It's Daoki Digital Clock DIY Kit 6 bits C51 AT89 C2051 chip. Electronic Alarm Clock Kit, PCB board soldering practice FR4 for Arduino with battery holder. Okay, first of all, I'm not sure what the Arduino thing has to do with any of it. It is a digital clock kit, and let's see if we can find a better picture. We'll go to the first one here, and that'll give you a rough representation of what this is going to look like. It's a 6-digit clock. It has 3 buttons. It has 2 options for the power, and we might end up switching off of those and seeing if we can do the USB mod on this one, but that'll be later. My first goal is just simply to get this thing built. Let's take a look at sort of the exploded diagram of, wow, it's a little fiddly today. There we go. Come on. There. So that's all the components kind of laid out. That's a different shot of the components laid out. Here's the front and back of the circuit board. Here is, now basically this is using a microcontroller chip called the AT89C2051, which is what they're mentioning in the title for this. There is a circuit diagram, though. Let's see. Can I actually blow it up? Yeah, so if there are issues, we might be able to refer back to this. Oh, and here's a bigger version of the circuit diagram, or at least it's solo. So let's read the description here. Great school science project. The DIY clock kits are used to installed to a 4-digit digital electronic clock. It is widely used in schools to help students learn basic mechanical and electronic skills. Okay, first problem is a 6-digit, not 4, which I think means it has the seconds. Easy assembly. In addition to teaching basic mechanical and electronic principles, the clock kit is easy to build and is so simple. We'll find out. Wide time functions. Wide functions with clock, time set, alarm set, countdown timer, stopwatch counter, hourly chime, precise time display, and 24 hours format. Accurate travel time, the error range, plus or minus 1 second every 24 hours. Well, so in 2 months you're off by a minute. The electronic clock kit is equipped with AT89C2051 master chip. It's a microcontroller that's been pre-programmed. Military grade FR4 PCB board, size 7-inch by 2-inch. 2-inch? I'm going to have to look at that. Comes with a 150 millimeter power supply wire for DC 7 to 12 volt voltage input. Typical applications is 9 volts. Alright, well, we'll have to see how all this is going to work. What I want to scroll down here and see if there's any more information. YCL6 makes the full use of the single chip resources, which is featured with the function of alarm clock, countdown clock, stopwatch, and counter. Circuit is mainly composed by the single chip circuit. Okay, this is... I'll let you read the listing. I'll post the link in the description below. Well, there is more information here. Let's see. 1. Single chip circuit. It's based on that processor which including the power on reset and clock circuit. Power on reset. Oh, there's no battery backup. That's kind of important. I hadn't really thought of that when I bought this one. The advantage of a battery backup is you could have like a watch battery in there. And what that does is maintain the system at just a high enough voltage to keep things running so you don't lose the actual clock. It's like if the power goes out in your house and the clock starts blinking. So that would mean that if I disconnect the battery and there's no battery backup, then I have to reset the clock again. 2. Display circuit. The main component is a 2-bit digital tube in red. Okay, well there's 3 of those. Let's see. The driver uses the PNP transistor and it's equipped with current limiting resistance at every port. It's with scanning driven way and uses P1.0 to P1.6. The colon part uses 4 pieces of diode. Oh, okay, that's supposed to be a 3mm red with scanning driven way, and it uses P1.7. So basically they're telling you which ports they're using. 0 to 6 for the 7-segment displays and 7 for the colon. Keyboard input, the keys S1 to S3 are with reused function, which reused with the display part of P3.5, 3.4, and 3.2. So different ports on the process. Basically, a microcontroller is going to have inputs and outputs, and what they're talking about is the outputs here. And here's the operating principle. Output high level at the related pin to read out the status of keys and debounce via single chip system to give the keys with corresponding value. Okay, debounce is something that basically when you push a switch, there's usually a little bit of a vibration when you're pushing it down. You don't necessarily notice it yourself, but if you have a sensitive enough system, it's going to read it as multiple key presses. So what they do is they basically average it out. That's probably the simplest way to put it. There are simple circuits for debouncing a switch, and I think they're saying that they've got that built into the processor. I mean, if the processor's running fast enough and it gets multiple key presses, it's probably just going to say, okay, well, all of those key presses came within a fraction of a second, so it was probably only intended as one key press. Number 4, signal ringing circuit. It's composed by buzzer and PNP transistor, and the operating principle is that the buzzer will send sound in fixed frequency after the PNP transistor turns on. It's with independent port-driven way and uses P3.7. J1 is used for connecting the extra control equipments, which will output the low level when there is no ringing signal or high level with ringing signal. Okay, so this lends itself to hacking, hacking in the sense of adding functionality, in that it has an external port so that if the alarm goes off, you could control something. You need to build the circuitry to do that, but that's kind of a nice feature. Number 5, power circuit. It's composed by 3-terminal integrated circuit, which will supply the whole system with the stable voltage. 3-terminal, oh, basically it's got a power, a voltage regulator. Be curious what voltage regulator that is. But package includes the kit, the battery holder, and a battery wire. I don't think there's any more information here, and there's no actual instructions for assembling it on the listing. So let us leave the listing here, and we'll come back live, and we'll see about unpacking this thing and what parts we have. I do see Oh wow, it's a bigger bag than I thought it was. There's a bag inside the bag. Whoops, sorry about that. And okay, I can get rid of the bag. There is a 1, 2, 3, 4, 5, 6 cell. I believe that's a double A. Let's try one of my double A's. Yep, that appears to fit a double A. I have to make sure these are charged. Wow, it's fighting me. See if I can get it to go in there. There we go. Okay, that is double A. There's 6 of them, 6 times 1.5 volts. This is a rechargeable. It's not 1.5, it's 1.2. But if you put alkaline batteries in there, conventional non-rechargeable batteries are 1.5, so 6 of them would make 9 volts. The other alternative is the 9-volt battery snap. So those two are included, and unlike the last kit I built, this one seems a bit less cheap and isn't broken. Let me put that battery aside, and then let's see what we've got in here. In fact, let's get our mat out, and we can spread out the parts. Alright, I probably need to fix the lighting in here because I'm not seeing this as well as I should. Wow. Gonna fight me. There's a piece of tape there that just won't let go. There we go. That's gotta be it. And that's also a larger bag. We'll dump everything out. Oh, some pieces got caught on the tape. That'll be one question, is did they include spare parts just in case? Or if I got exactly what I need. And there is the board. That looks more than 2 inches to me. Let's get a ruler. I'll put this up in centimeters for anybody that's interested, but let's see. It looks like we've got 4 inches wide, 2 1/4 inches, give or take, 2 3/16 tall. So, yeah, 7 by 2? I don't think so. That's a strike against them. Let's see if the instructions are entirely in Chinese like the last one. Yeah, it's kind of looking that way. Yep. Alright. Can anybody out there actually read this? I could put this up under Google Lens, I believe it's called, which would then translate the Chinese. But I'm going to attempt to do this myself. One thing, though, it looks like we might have... Oh, wow. I was going to say, we might have a parts list. Yeah, we kind of do. I can't tell exactly what all it's saying. I can see some parts I recognize, though. It looks like we're supposed to have 7 of the 7 of one particular resistor. Okay, the 220 ohm. We're supposed to have 9 of the 1K, 1 of the 10K, 1 at 0, which is probably a jumper, 1 at 5.1K, 2 capacitors at 30 picofarads, 2 capacitors at, what does that work out to, 10 and 4 zeros would be 100,000 picofarads, or what, 0.1 microfarads, I believe. It looks like there's a crystal at 12 megahertz, 3 6x6x5, which is probably these, where are they? Probably these 2-digit 7-segment displays. Alright, let's start kind of figuring this out here. Because the resistors are different numbers of each, so I should have 7 of the 220s. 1, 2, 3, 4, 5, 6, 7. No, that's more than 7. 1, 2, 3, 4, 5, 6, 7. There's your 220s. Let me actually have them sticking off the top here. And we should have 1, 2, 3, 4, 5, 6, 7, 8, 9 of the 1K resistors. That means there's got to be more resistors in here. Here's a single resistor. Let's hope we don't have... Oh, we got a bunch of those. I'm going to have to get out the magnifying glass and figure out what that is. We've got some kind of inspection sticker. We've got a piece of styrofoam which I'm guessing was supposed to contain the 7-segment displays. So we'll have to watch for bent pins here. This is not boding well for this particular manufacturer. The seller may not have anything to do with this. This is somebody's decision to just throw everything into the bag without actually sticking these things into, or actually putting them in their original packaging. We've got a chip, and I'm trying to get to the resistors here, but I'm trying to peel everything off of everything else. I've got a chip and I've got a socket, and that's kind of interesting how they packaged them together. I'll put that off to the side. This will be our speaker slash buzzer right here. Let's find, okay, there's another resistor. And one more. Well, let's ignore the resistors for a moment. We'll come back to them. I need 2 capacitors at 30 picofarad. Okay, these are electrolytic. Oh, okay. Wow. Yep. I need glasses and a magnifying glass to figure this out. Alright. Okay, the 30 picos should be smaller than the others, I think. It looks to me like these two are about the same size. And then I get 2 more at this size. And I have a couple of electrolytics. I'm just going to sort everything at this point. Trying to find something and then dig through the pile to find something else. It's less productive right now. That's a transistor. We'll put all the transistors here and hope that they're all the same. And another one. And we've got some LEDs. We'll put them over here. Just being able to sort this stuff out does make assembly a little bit easier. And with a magnetic mat, hopefully things will mostly stay where they are. So, okay. Just verifying that we have everything we're supposed to have. Going back to the list. 30 picofarad, so let's see if I can read anything on here. Wow. $30. Alright. We'll go for the 30s first because they're first in the list. That's 30. And so I'm hoping these say 104 because that's what the listing is saying. Now these are common components. If you really got yourself in trouble and something broke, then you can order replacements. You just gotta know what you're looking for. And unfortunately everything here is in Chinese, so in terms of specifications all you get is that it's a capacitor and it's 104. Moving on, we've got the crystal. That should be 12 megahertz there. And the way you would know that is you would look on the top of the can, if I can orient it. Yep, 12.000. So 6 by 6 by 5, that's got to be these things here. The 7-segment displays. We've got the chip and a socket. Yep, that's this here. We've got a 78 LO5. Where's my regulator? Well, let me see. I'm going to look at the diagram here. Try and figure out where they're saying they're installing the regulator. Yep. 78 LO5. That would be this component right here with the funny kind of almost triangular shape and 3 pins. So it is entirely possible that one of these things that I thought was a transistor is actually the regulator. I don't have anything else in that shape, but this is similar to that. This is like, yeah. In fact, if you look at the transistors here, these all have that same shape. So now the fun part is I've got to separate out. I've got to find a 7805. It's a 5-volt regulator. That's interesting. They're saying the supply voltage is 9 volts. They're regulating it down to 5. Oh man, did I get... Okay. Yep, I got lucky. 78 LO5, the very first one I picked up. So I'm going to put that up here. The 8550. Okay, that's going to be these. And there should be 7. 1, 2, 3, 4, 5, 6, 7. Oops, sorry about bumping the camera again. Still trying to figure out how to mount the camera and do this properly. 5 volt U3. Okay, there should be... I'm going to skip over that for a second because I'm looking at these electrolytics, and they are 10 microfarad 50 volt and 10 microfarad 50 volts. So I don't know if I'm going to be able to get that to focus, but that is, you know what, I'm going to try something a little different here. I'm going to tell the camera to focus right there. Did that help? If it did, I will put a still and zoom in. Alright, so those are both the right electrolytics. 2 jumpers. No, wait a minute. Oh, a 2-pin. I'm trying to interpret the numbers within the Chinese. And this is that's jumper 1, this is jumper 2 and 3. And the PC board itself, which I have off camera. So going back to the 2 that I couldn't quite figure out. Okay, so we got to have 3 of the switches. Okay, I see those. I'm supposed to have 4 of the LEDs. That makes sense. That only leaves one thing. Oh, okay, it's got to be the buzzer is a 5-volt buzzer. Okay. That's starting to make some sense. Okay, so now we've got our parts sorted, except for the 3 resistors, but we'll come to that in a minute.